Hello students. So in this video, let's start with the second exercise on areas related to circles. So the first question, find the area of the sector of a circle with radius 6 centimeter if the angle of the sector is 60 degree. Okay. Now remember, whenever the angle is less than 80 degree, then it should 180 degree. I'm sorry. If whenever the angle is less than 180 degree, then the sector is a minor sector. If the angle is greater than 180, then it becomes a major sector. Okay. So here radius is 6 centimeter. Okay. And the angle theta is given as 60 degree. The formula to find area of the sector is obviously it's a minor sector. The formula is theta by 360 degree into pi r square. Now remember, to find the major sector also you can use the same formula provided the angle is greater than 180 degree. Okay. Now suppose they have given you the angle as 60 degree and they're asking you to find the area of the major sector, then you're not supposed to use this formula. Okay, then in that case you have to use the other formula, that is 360 degree minus theta divided by 360 degree into pi r square. This is the formula that you're gonna use. Okay, so remember, if the reflex angle, that is if it's greater than 180, it's called reflex, right? If reflex angle is given directly, you can use this formula. If not, you have to use the other formula. Anyhow, in this case, the theta is 60 degree. Okay, so let's substitute 60 by 360 degree into pi is 22 by 7 into r square. R is what? 6 square. So 6 square becomes what? 36. So 60 by 60 degrees, 60 degrees by 360 degrees into 22 by 7 into 6 square is 36. So actually you can cancel 36 ones are 36 tens are. Again 10 ones are 10 6 are. So what we are left out is now 6 into 22 by 7. So 6 into 22 by 7. 6 twos are 12, 1 carry. Again 6 twos are 12, 12 plus 1 is 13. So 132 by 7 centimeter square. That's the required area. Okay, so area of a sector is given by what formula? Theta by 360 into pi r square. You know the value of theta, you know the value of r, substituted and calculated. Remember, only if they mention the value of pi we have to take it, otherwise pi value is 22 by 7 in all the calculations. Now find the area of the quadrant of a circle whose circumference is 22 centimeters. Now what is this quadrant? Let's take a circle. Okay, now let's draw two diameters in such a way that they are perpendicular to each other. Let's say this is one diameter. Okay, let's say the center is at here. Okay, let's take another diameter such that both these diameters are perpendicular to each other. Okay, something like this. You can see the angle is 90 degrees, isn't it? Now if you see, the circle is divided into 4 equal parts here. Okay, first part, second part, third part, fourth part. Now each of this part is called as a quadrant. Okay, so the thing that I'm shading is called as a quadrant. In another word, quadrant is actually a sector. It looks like a pizza itself, right? Quadrant is actually a sector, but the thing is the angle, the central angle, the angle at the center is 90 degree. Okay, so quadrant is also a sector, but what is the specialty? The angle at the center is 90 degrees. Okay, so that's the quadrant. Okay, so if it's a quadrant, so you can, or let's derive the formula itself for area of quadrant. That will be very, very easy. You can also note down this formula, area of quadrant. Actually, what is a quadrant? Quadrant is also a sector. So we have to use the sector formula, theta by 360 into pi r square. Now what is theta? Theta is 90 degree, because in a quadrant the theta is 90 degree. So theta by 360 degree into pi r square. Now 90 ones are 90, 94s are 360. So what you're left is 1 by 4 pi r square. Therefore, you can note down this formula, area of a quadrant. Okay, area of a quadrant is given by the formula 1 by 4 pi r square. Okay, so you can note down on the formula list, area of a quadrant is equal to 1 by 4 pi r square. Now, if you want to find the area of the quadrant, you need the radius, right? But the radius is not given. Okay, instead what they've given us is the circumference of the circle. Okay, so circumference of circle, circumference circumference is equal to 22 centimeters, isn't it? What is circumference formula? 2 pi r. So 2 pi r is equal to 22. 2 into pi is 22 by 7 into r is equal to 22. So we don't need the send 7, send it other side. 2 into 22 into r is equal to 22 into 7. Okay, 7 was in denominator, so we have sent it the other side. Therefore r is equal to 22 into 7. 2 and 22 comes to the denominator. So 22 gets cancelled. So what we have found is r value, which is 7 by 2. R value is 7 by 2 centimeters. Now let's find the area of the quadrant. We know that area of quadrant is 1 by 4 pi r square. So 1 by 4, pi value is 22 by 7 and r value is 7 by 2 whole square, isn't it? R is 7 by 2. Since square is there, we have squared it. So 1 by 4 into 22 by 7. 7 by 2, the whole square can be written as 7 by 2 into 7 by 2, isn't it? So 7 gets cancelled. 2 1s are 2 11s are. So what is left out? 1 by 4 into 11 into 7 by 2. So let's multiply. 11 into 7 is 77. 4 into 2 is 8. Therefore, the answer is 77 by 8 centimeter square. That's the area of the quadrant. Okay. Let's insert a few. Okay. So area of the quadrant is 77 by 8 centimeter square. Okay. So let's get into the next question. Before getting into the next question, okay, actually we can find the length of the arc. Okay. Before getting into this question, I forgot to mention this formula. We can find the length of the arc. Okay. So any arc, minor arc or major arc. Okay. Length of the arc is given by theta by 360 into 2 pi r. Also note down this formula. Okay. Length of the arc is equal to theta by 360 into 2 pi r. Again, if it is a minor arc, you're going to use this. If it is major arc, then we are going to use this formula. 360 minus theta by 360 into 2 pi r. Okay. So same, it is exactly the same thing like the sector. Okay. In sector, we use sector is the area. So we're going to use pi r square. Here it's a length. So we're going to use 2 pi r. Okay. Now coming to the third question. The length of the minute hand of a clock is 14 centimeter. Okay. The minute hand length is 14 centimeter. Find the area swept by the minute hand in 5 minutes. Okay. So let's take a clock. Obviously, clocks are also in square shape. Okay. But let's take the circular clock. Okay. Usually clock we take circle shape. Okay. Now we have hour hand, minute hand and the seconds hand. Okay. But we are focusing only on the minute hand. Okay. So let's say this is the minute hand. Okay. Now the minute hand might be anywhere. Okay. Let's say this is 12 o'clock and 6. Okay. Let's not mention all those. Let's just pictorially represent that it's a clock. That's it. Okay. Okay. Now, what we are supposed to find is the area swept by the minute and in 5 minutes. Okay. Let's say it is at 2 now. Okay. Here it is 3. After 5 minutes, the minute hand will be here, isn't it? After 5 minutes, the minute hand will be here. Now, what we are supposed to find is, if you observe here, it has covered some area, right? As I'm shading, that is the area that is covered. Here, this is the area that we have to find. And if you observe, this is looking like what? It is looking like a pizza shape, okay, or a cake shape. And I have told you if it's like a pizza shape, it is a sector, right? So this is actually sector. So what we are supposed to find is sector, area of the sector. And here, the length is 14 centimeter, which will be acting as the radius. Okay, the length of the minute hand is acting like the radius. So radius is 14 centimeter. But what is the formula for area of sector? Area of sector is equal to theta by 360 into pi r square. That's the formula. But we don't know the value of theta, right? Only if we know the value of theta, we can find it. Now let's find theta. Now how do we find theta? Very simple. See, in 1 hour, in 1 hour. Say suppose the minute hand is at 2. After 1 hour, see in 1 hour it goes one rotation and comes back again to root 2 itself, right? So wherever it started, it comes back to that place itself. In 1 hour, okay, in 60 minutes, it makes one full circle. That is, the angle covered is 360 degree, isn't it? So in 60 minutes, the angle that it is describing or inscribing is 360 degrees. So in 5 minutes, what will be the angle that is formed? Okay, cross multiply 5 into 360 divided by this 60. Okay, 60 ones are 60, 66 are. Okay, or 0 gets cancelled, 6 6 are. So 5 6 is 30. So the angle formed is how much? 30 degrees. Okay, for each 5 minutes it will be 30 degrees. Okay, so the theta is 30 degrees. So 30 by 360 into pi, which is 22 by 7. R value is 14. So if it is 14 square, so let me write it as 14 into 14. So 0 gets cancelled. 3 ones are 3, 12s are 7 ones are 7, 2s are 2 ones are 2, 6 are 2 sevens are 2 3s are. So therefore it will become 22 into 7 is left out in the numerator. In the denominator it is 3. 22 into 7 is 154 by 3. 154 by 3 centimeters square. So this is the area that is swept by the minute hand in 5 minutes. Okay, let's get into the next problem, students. Find the, okay, a chord of the circle of radius 10 centimeters, substance, a right angle at the center. Find the area of the corresponding minor segment and the major sector. So there are two things that we have to find. One is the major sector area and the other one is minor segment area, and they have given the value of pi as 3.14. So here in this problem, remember, we have to use the pi value as 3.14. Okay, first let's draw a circle. Okay, now let's take a chord. Let's say this is A. Okay, and let's say this is B. Let's draw the chord. What is a segment? Segment is the region between a chord and the arc. Okay, so they have told minor segment, obviously the bottom shaded part. This is what we have to find. Okay, let me take up another point on the circle. Let's say C. Okay, now usually we say how do you represent mathematically the segment? How do you write it? We write it like this. We start with A and we end with A itself. So the segment name will be A, C, B, A. Okay, that will be the segment name. Okay, so area of the minor segment. The first thing that we have to, okay, what is given? Let's write that radius is given, that is 10 centimeter. Okay, and we have to find area of the minor segment. Okay, area of minor segment. What will be the name of the segment? The name of the segment will be A, B, C, A. Okay, that will be equal to, and they have given a chord of circle, subtends right angle at the center. That is, if this is the center, and if you join the end points to the center, okay, if you join end points to the center, the angle formed here is 90 degree. That is what is given. Okay, here the angle is 90 degree. Okay, now we have already seen what is the formula of the minor segment. Area of the minor segment is area of minor sector. What will be the name of the minor sector? The name of the minor sector is, it starts from O, right? O, let me trace it. O, A, then it comes to C, then B, then goes back to O itself. This region is called as minor sector, right? O, A, C, B, O. That's the minor sector area. Minus area of the triangle. What is the triangle? AOB. Area of triangle AOB. Now, how do we find area of the minor sector? Theta by 360 into pi r square. That is the formula. And how do we find area of a triangle? Area of a triangle is given by the formula half into base into height, right? Now, before substituting, is there anything common that you can take? No, there is nothing common. So let's not take it. Now, theta is given as 90. So 90 degrees by 360 degrees. Pi value, if you remember, they have given it as 3.14. and radius is 10 square minus half. Now, which is the base? Let's take, since it's a right angle triangle. See, if you observe AOB, it's a right angle triangle. Okay, in right angle triangle, we can take OA as the base. If I take OA as the base, the other side OB will act as the height, isn't it? What is the height? It is the perpendicular line to the base. So if you take OA as the base, which is the perpendicular line to the base? OB is the perpendicular line. So OA will be base and OB will be height. Okay. Now 90 by 0 gets cancelled. 9 ones are 9 fours are. So what we are left is 1 by 4 into 3.14. 10 square is 100 minus 1 by 2 OA value. What is OA? OA is the radius of the circle. And what is the radius of the circle? 10 centimeter. OB is also radius of the circle, that is also 10 centimeter. So OA is also 10 centimeter. OB is also 10 centimeter. So if you cancel it, 2 ones are 2 5s are. You can cancel that. So what you're left is 1 by 4 as it is. As you can see, 3.14 into 100, that will become 314, isn't it? If you multiply by 100, you have to shift the point twice towards the right side. So it will become 314 minus 5 into 10 is 50. Now let's try to cancel this. 2 2s are 4. 2 1s are 2, 1 carry, 2 5s are 10, 1 carry, 2 7s are 14. So what we are left is 157 by 2 minus 50. Now what is 157 by 2? Half of 157. That will be equal to, if you can divide it here itself. 158 half is how much? 75, 79. So it will become 78.5. Okay, you can check it. 78.5 minus 50. That becomes 28.5 centimeter square. That's the area of the minor segment. Okay. Now, let's find area of the major sector. Okay. Let me do it here itself. Okay. Area of major sector. Area of major sector. Now we have to use the other formula, right? 360 minus theta by 360 into pi r square. This is the formula that we have to use. So 360 minus theta is 90. Let me do it directly. 360 minus 90, that becomes 270. 270 by 360. Okay. Into pi value is 3.14. R square is 10 square. 10 square will become 100. So I have done it directly. So here it is 360. So 0 0 gets cancelled. If you cancel by 9, 9 3s are 27, 9 4s are 36. So into 3.14 into 100 is 314. So if you cancel it again, it becomes 2 2s are 2, 157s are. Okay. So 3 by 2 is 1.5 into 5, sorry, 157. So if you multiply 1.5 and 157, you will get the answer. That is the area of the major sector. So let's get into the next question. Okay. In the next question, we have got a circle of radius 21 centimeter. An arc subtends an angle of 60 degree at this center. Find the length of the arc, the area of the sector formed by the arc, area of the segment formed by the corresponding chord. Okay. So let's take a circle. Okay. Let's take a circle like this. Now let's say this point is A and let's say this point is B. Okay. Now let's say this is the center. Okay. Now let me show the arc using another color. This red color which I'm tracing out is the arc, right? Is the minor, some arc. Okay. This arc, when you join the end points of the arc to the center, okay, the angle formed is 60 degrees. This is given. Okay. Now what we have to find is the first thing, length of the arc. Let's find that easily. Okay. Length of the arc is given by what formula? Length of the arc, that is given by the formula theta by 360 into 2 pi r, isn't it? So theta is how much? 60 degrees by 360 degrees into 2 into pi is 22 by 7 and radius is 21 centimeter. So 0, 0 gets cancelled. 6 ones are 6, 6 are 7 ones are 7, 3s are. So what is left out? 1 by 6 into 2 into 22 into 3. So as you can see, again you can cancel. 3 ones are 3 twos are 2 ones are 2 ones are. So that thing that you're left is 22 centimeter. That's the length of the arc. Okay. So we found the length of the arc. Next thing that we have to find is area of the sector. So area of sector. See, the length of the arc is arc AB. Okay, that's the thing that we have found. Length of the arc AB. So area of the sector name is OABO. Okay, or let's take a point here. Then it will become OACBO. Okay, area of the sector is given by the formula theta by 360 into pi r square. So theta is 60 degrees divided by 360 degrees into pi is 22 by 7. R square. So R is 21. So R square will become 21 into 21. So 61s are 66 are 7 ones are 7 3s are again 3 ones are 3 twos are. So what is left out? 1 by 2 into 22 into 21, isn't it? So 2 ones are 2 11s are. So 11 into 21, that becomes 231. Okay, if you multiply it, you get 231 centimeter square. This is area, so the unit will become centimeter square. The next thing that we have to find is area of the corresponding chord. That is, if you join A and B, you get chord, and you got the corresponding segment here, right? The minor segment. So we have to find the area of the minor segment. Okay. Now, let's find the area of the minor segment. The area of minor segment. Okay, what is the formula? Area of sector, which we have already found it, minus area of the triangle. What is the triangle name? OAB, and the sector name is OACBO. That is the sector name, and this is ACBA. Okay, those are the names, okay, of the minor segment and the sector. Okay, now remember, whenever the central angle, that is the angle at the center is 60 degree, the triangle that we have got is an equilateral triangle. Let's prove that. Okay, actually OAB is an equilateral triangle. Let's prove that. How? Very simple. OA and OB are equal, isn't it? Because they are the radius of the same circle. So OA value and OB value are equal. Now this becomes an isosceles triangle. If two sides are equal, then two angles are equal. So this angle and this angle will become equal, isn't it? So that is, angles opposite to equal sides are equal. Okay. So let's say this is X and let's say this is X. So if you add all the angles, 60 degree plus X, that will become equal to 180 degree. Sum of three angles is 180 degree in a triangle. So 60 degree, if you send it the other side, X plus X is 2X, 180 minus 60 is 120. And if you find the value of X, it is 60 degree, which means here X is, here X, here also X is 60 degree, here also it is 60 degree, which means we have got a triangle in which all the angles are 60 degree. If all the angles are 60 degree, then it's an equilateral triangle, right? And once again, in one of the formula, that is in the first video, okay, let me check with the formula of the equilateral triangle. I guess I might have made a mistake. Yeah, area of an equilateral triangle, I've made a mistake, I'm sorry about it. Root 3 by 4 into side square, that's the formula. Okay, root 3 by 4 into side square. Okay, root 3 by 2 into side is the altitude of the triangle. Okay, let's get into the next thing. Okay, now here area of sector, we have already found it as 231 minus area of an equilateral triangle. Area of an equilateral triangle is given by the formula root 3 by 4 into side square. What is side? Side is OA, OB are the sides, right? OA is what? Basically the side radius. So radius is how much? 21. So 21 square. Okay. It is 21, right? Yes, the radius is 21. Okay. So 231 minus root 3 by 4 into 441. Okay. Here 21 square is 441. Okay. Here we cannot subtract it because 231 is a rational number. Root 3 by 4 into 441 is an irrational number. So let's stop it here itself. So many centimeter square is the area of the segment. Okay. So we'll continue with the problems, the remaining problems in the next video. Thank you, students.